How's it going, folks? It's Juno here. There are a couple problems with some of the responses I've had to the video I made the other day about blue-green algae cyanobacteria. I'll acknowledge that it wasn't the most verbose video out there. I could have given more explanation, but I felt like I wanted to just get some key points across in a palatable version that people will be able to understand. But no, fair enough. I've had some feedback about areas that I could have given more specific explanations for and elaborated further. So let me go ahead and do a short video about some of the difficulties in effectively transmitting messages regarding difficult technical subjects. Alright, so with the subject I was discussing, for example, I was able to use a number of studies that were publicly sourced, publicly available at least. And firstly, let me just say thank you very much for all the organizations and institutions that allow those studies to be made public, because they allow amateurs and just interested parties to take a look at the data and see if they can use their individual creativity and imagination to try and find new perspectives on troubles that are still looking for solutions, problems that still need solutions. So I'm obviously hugely appreciative that those are made available for everyone, and looking forward to a more automated future where we're able to utilize deep learning techniques and maybe even AGI and things like that. Hopefully, human intervention will be no less required or no less productive than it is now. And I predict that we'll be able to still provide things like a creative perspective on a problem. And with our biological brains, we're able to make inferences about some of the data that's not being included in the original data set. And then because of our innate ability to use that inference, we can then come at it from a different perspective. Okay, now that's probably going to lead me on to my first point. So it's a point about statistical data. So I apologize, I haven't really set up any visual for this, so I'm just going to leave the screen basically blank for now. But let me talk for a moment about the difficulty of operating with statistical data. So if I was to bring up studies about a condition, the studies usually take place in a specific geographical location. Now, historically, all of the studies were done in proximity to the institutions that were funding the studies or where the studies were taking place. So, like, historically, I don't know, in like Victorian era or whatever, the institutions that were running the studies would be running, on their local population or on a locally afflicted population with a certain condition or a certain scenario they were trying to solve. So the data set would have value in that context, but outside of that context, the value of that data set would change. Now, in dealing with the subject of cyanobacteria, some of the difficulties in viewing the case studies and statistical analysis is that you're looking quite a few steps down the road for signs and signals that could suggest a connection. So you're having to use that inference of yours to assume that you're somewhat familiar with how it could be causally connected. If I was to take data from a US source, for example, that covered mostly US participants in a study, there is a global context to the demographics of the US in that study, right? Like, it may not account heavily for Asians, for example, because predominantly the US is not an Asian majority continent. So would you be able to use the data from that study to contribute to an understanding of a condition in, for example, the Asian context or the context of the Asian continent? And I'm not sure that would be as valuable as one that was locally sourced from an institution in mainland Asia. Nevertheless, as I said, historically, we have built a library of studies and a library of data, a large database, in the literal meaning of the word, that we may sometimes take as a given as, these are the clinical signs and representations, this is the clinically significant data for this particular condition, when actually it was only done in a specific location that only affected a certain population. I understand that from perspectives today, it's not always considered advantageous to identify, for example, genetic differences in different populations. I understand that's the case, and I understand that institutions are somewhat pressured to not pick sticky subjects like that are going to cause them grief. Because if it begins to look that way, and they are, bound to represent that data honestly, that could, as I said, that could actually be damaging for the institution in the political climate. Now, obviously, what I don't want to happen is for it to fall solely on amateurs to have to fill the gap there from an anonymous position, because they'll never be accredited, right? Like, I don't for a minute imagine that any of the work I do in my own time is going to be taken seriously by any academic institution. Even if I did draw the correct conclusions, I'm not presenting my evidence in such a way that it would be admissible on the standard required by academic institutions. But nevertheless, I don't desire any credit in this. If any of my work can at least supply inspiration for anyone, for a professional in the field to look at something slightly differently in a productive way, as far as I'm concerned, that I'm happy with that outcome. That's productive for me. But back to the statistical significance. All right. So if you just take data points from a set, without the context of where they occur in the set, you actually lose some of the inherent data itself. Like, the data is less valuable being presented that way. Now, you can only really present the data as it appears in the study itself. If you were to start making assumptions about the study to help contextualize it, however, well-intended you are, you might be corrupting the data. So, well, as I said before, a lot of the studies that we have done in fundamental fields, especially clinical sciences, were done a long time ago, and were done with very specific populations as their subjects. They wouldn't necessarily be globally applicable. So it's all, obviously it would be advised, if it was financially feasible, for institutions to essentially rerun a lot of fundamental studies over a set time period to accommodate for changes in environment, for changes in human development, for changes in popular genetics. I mean, that literally is in, like, as the genetic pool changes in a given population over time, it may be prudent to reanalyze the original data and see if it can still be applied in the same way. But yeah, if for example you were taking data purely from cohort studies in the US, there is a huge disparity across that continent, but it doesn't cover everything. Would you have the same conclusions if the same study was done in sub-Saharan Africa? I don't believe you would. Historically, there's been some precedent to say that a lot of studies have been done primarily on men, and so the male model has been used, and that isn't always a very accurate diagnostic tool when applying the same conditions to women. So, more women's studies would be required to accommodate for that on some level. I'm not saying that the differences are vast. I'm saying the differences could be significant. And that is enough, in my view, to promote further research in that area. And I would view it entirely the same in terms of racial groups as well. That the differing racial groups may have different adaptations, different relatively common genetic pools in certain areas, genetic variety. And it would be worthwhile, in my opinion, to put studies into context when considering significant data. Data that needs to be included in any retrospective view. Alright, so that aside, that point made, I think, in reference to my last video, had there been more information available for a wider analysis of the topic, I would have loved to include it. I don't think there was much in terms of high quality analysis done on such a broad area. But nevertheless, I hope for some portion that I did investigate, that the conclusion was somewhat supported with that evidence. Another point that I think might be significant to bring up is some of the hypotheses that I didn't include in that original presentation. The presentation obviously was, I had a specific desire that I wanted a concept to be communicated. but there was some genuine criticism, valid criticism, I think, that I didn't allow for a variety of opinions to be at least acknowledged. I did say that I understood that the view I was delivering was not an orthodox one, and was one that was actually still actively being researched. So I understand that could possibly change over time. However, there have been other things brought to my attention since then, which I also think are very interesting. One of them is the study I'm looking in front of me now. So this is a study which investigates whether or not it's actually a relative frequency and population of gut flora and fauna that indicate whether or not someone may be more susceptible to certain types of neurodegenerative conditions. Now, I've known for some time that there is a relationship between the gut and the brain. Obviously, on a very simplistic level, the nutrition that goes into the brain has to come from somewhere, and that's obviously going to come from the main system that you have for extracting nutrients from what you consume. So clearly there has to be some biological checks to ensure that it is safe to enter that very sensitive area. There is a number of barriers to entry. The blood-brain barrier is notoriously difficult to gain access to and to transit successfully, especially from a pharmaceutical perspective. So there is probably a strong argument to be made about some influence that the biomass in the gut can have over your absorption of potentially harmful toxins that can affect neurological function. Now, this specific study essentially is, again, it's sort of retrospective. It's combining a number of other studies that have, in at least some way, shed some doubt on quite specifically on the perspective I was proselytizing in the last video. And these would culminate in its conclusion to essentially saying that it may appear that actually in some situations, some sort of interference in gut flora fauna, this could be antibiotic interference, this could be dietary changes that have an effect. I think at one point it talks about probiotics replacing a number of your otherwise healthy gut bacteria, intestinal bacterial population. And that this actually, because there's some sort of bacterial competition, and if this one bacteria gets competed out, the body loses some of its ability to correctly absorb or remove BMAA, which I think is, again, it's reasonable. It's reasonable enough as an assertion to at least warrant investigation. So I'm happy for it to be out there. And I would even say that I don't think it's wholly, it's not wholly contradicting my view. I think my view can be complementary to this in some way. While my view actually was more heavily based on the aspirating cyanotoxins, microcystins. I still think there is a strong component of it that is taken in through the gastrointestinal tract, and I'm happy to admit that could be the case. And again, as I said, I am aware of a very strong and very significant connection between gastrointestinal tract and the CNS. So it seems at least possible for me that this could be the case, and I think it's well worth further investigation. And in addition to what I said earlier about there being statistical issues with data, it may very well be that the populations that live in certain areas like sub-Saharan Africa, where there has been a propensity for higher temperatures, maybe more CO2, maybe more phosphates, maybe there is more of a natural resistance to neurological damage in this way, though it's difficult to tell because from the studies I have read that do contrast and compare. Now, there aren't many in Africa itself, but there are some, again, in the United States that contrast and compare African Americans with Caucasians and Asians. And they do seem to suggest on some level that while African Americans may present earlier, they actually present less. And again, that as a standalone statement only has limited value, because then you'd have to calculate for, okay, even if in that population there's 15% African Americans and only 6% of them, they're only comprising 6% of the patients. Are there other factors involved? Could it be that they're not reaching senescence, so they're less likely to ever present because they're not ever reaching the age, or they're less likely to reach the age that they would begin to present with, because they're dying from other causes earlier on. So, take that as it stands. But nevertheless, I thought this was a very interesting study, and I would recommend anyone who's interested to just at least browse it and take a look at it. It's obviously, I don't think it draws strong conclusions necessarily, but at least in the in the hypothesis, I think it's a very interesting thought and concept to look to the future for. If there will be any further studies, I'd be very interested to see, specifically in this region, whether or not there'll be results released that we can analyze. Okay, so again, to give all due respect to other hypotheses that are out there, I want to say I was aware before I made the video, and I hope I paid at least some attention to addressing the fact that repeat concussion or repeat brain cranial impact, or impact generally on the body of a certain threshold, does seem to be somewhat associated with outcomes in terms of neurodegenerative conditions. And I understand as well that I spoke at some length about cycling, for example, where a lot of people who go on to have ALS, especially in their 50s and 60s, do appear to have been cycling for extended periods beforehand, or while there's very little study data on that, the patient groups seem to represent in that way when surveys have been taken, though I would like more to be done from an official perspective in gathering that data meaningfully into studies. And before I actually made the other video, I did consider to myself if there could be, while not individual instances of concussion or concussive impact or cranial impact, whether there could be an accumulative process which would be related to, for example, snowboarding or skiing or cycling or, I don't know, skateboarding, things like this, where the suspension provided by the sports equipment being utilized is so minor as to not ameliorate the rapid vibrations and small impacts being incurred upon the CNS during those activities, especially when they're prolonged or repeated activities. And by that, what I mean is, well, if you consider someone who goes skiing, for example, the average skier isn't going for like a half an hour session or a 1 hour session. These are normally whole holidays, weeks dedicated to being on the slopes. And those areas are, the only suspension you're really provided is in the boots and in your knees, in the joints. So you're incurring, I think, quite significant amounts of vibration or non-suspension affected impact that would be having potentially like causing some level of micro tearing, for example, in the cerebellum or the cerebrum. And again, I'm just applying this creatively. I don't think there have been extensive studies done on that, though I would like to see them done. But I can imagine that being the case. I could also associate that with road bike users specifically. Mountain bike maybe less so. Mountain bike users tend to operate with less speed over shorter periods, whereas road bike users and the construction of a road bike is much less geared towards absorbing impacts and much more about streamlined straight line speed. So there'll be, like I said, much stiffer or less at all available suspension built into the frame of the bicycle. Some suspension being given by the construction of the wheels, of course, but then most of it then traveling up through the hands, which are attached to the handlebars, and then directly into the shoulders, neck, and the head. And as I say, people who operate in like amateur cycling clubs will be cycling for prolonged periods over a year round, annually, essentially. So they'll be going out for hours at a time, and they'll be doing it maybe once or twice a week, maybe more, and this is a behavior that will continue on if someone enjoys cycling, and it is promoted as a very healthy and somewhat low impact sport where you're not likely to have a major injury. But if these accumulated vibrations, accumulated small impacts, and basically energy traveling up, this shaking energy traveling up into your skeletal muscles, the skeletal system, but mainly towards your neck and your head, whether or not this is having an impact over a prolonged period and causing some sort of small incremental damage that does end up having these symptoms present. I'd be, again, interested to see more research in that area, but I can only really utilize the information that I have. So when I'm building a hypothesis, it has to be done with some level of information that I can call upon. And while there are other possibilities, if there is yet any evidence to be garnered on those grounds, it's very difficult for me to present them when I'm presenting my hypothesis. But I do acknowledge that, at least hypothetically, I think these are actually reasonable cases to bring up. Again, in the terms of, for example, winter sports or cycling specifically, but other things as well. I would be surprised. Well, look at it from an evolutionary perspective, for example. To some degree, we are evolved for the locomotion of running. All right, this is the kind of impact I think our joints, our skeletal muscular system, our organs, and ultimately our central nervous system are evolved to handle. And I think that inherently is going to provide a very certain and specific type of energy dampening buffer system. And now we know this is the case because, for example, athletes or individuals that have prosthetic limbs experience strains in very different ways, experience injuries in very different ways to fully abled athletes. So at least it does seem that there could be some compare and contrast on that basis, and there may be reason, again, for additional research in that area. So I suppose so far I've spoken a lot about the physiological aspect of it. The neurological aspect of things, well, I understand that from my limited knowledge of neurodegenerative diseases, there are a number of mechanisms that can be involved. All right. This is at least on the genetic side. So when they do genetic testing, they will identify sometimes that there is obviously a frequency which certain genes or some mutations do appear. But the problem with calculating for this is this layers of abstraction analogy that I used in the last video. I only used it very briefly, but if I just want to rehash it out here. Now, one of the treatments, one of the therapeutics that we can use specifically seems to have a mechanism to do with glutamate. And glutamate is a hugely useful resource in the brain. It is used in the synapses, in synaptic transmission. I think it's used in something like 90% of synaptic transmissions. It's one of the most used neurotransmitter or neurotransmitter mediums. So clearly it has a large influence. Now, if I want to view this from a kind of an engineering perspective, when you look at the effectiveness of some of these treatments, they're more than marginal, but they're not highly significant. And what this suggests to me is that in assessing their effectiveness, they're acting in the role of a kind of buffer. And what do I mean when I say buffer? So in natural systems, you will often have a number of mechanisms that cover a specific function. But they all contribute to that function, okay? So they may even be providing the same function, but they'll provide like one mechanism might provide 50% of the function, but there will be other mechanisms that run a secondary system that also supply the function to a certain degree, but not the totality of it. And this way of distributing functions amongst different mechanisms makes the human body, but most biological systems, actually incredibly robust, because you can then have very natural variances that the body can subtly calibrate for, and it allows you some space to, as I said, for these changes to take place, usually in just temporary nature. So, for example, dietary or environmental changes. And then because the body is able to make small adaptations on a temporary nature, that flexibility comes in very useful. So you can down-regulate one thing and up-regulate something else only by a fraction, but it allows for that to take place, especially if there's some level of deficiency that can be resolved given time. Okay, so in the glutamate response of some treatments, my suspicion is that while the mechanism isn't fully understood, what they may be providing from an engineering perspective is a type of buffering system. So where these multiple mechanisms can provide a certain level of functionality, glutamate synthesis is being boosted temporarily, and that is buffering. All right, so it's not a support. It's not providing the full array and the full requirements, but it is at least buffering on a temporary basis to compromise for some deficiency. And that's often why you see that these types of treatments are not long-lasting or having high significance, but nonetheless they are somewhat significant, and they do seem to add a little bit in terms of treatment. So when we analyze it in this way, that they're operating on a kind of buffer, but they're not able to resolve to resolve a solution in the long term. I think what is important to draw from that is that, as I said, multiple mechanisms converge on, at least in some cases, converge on a similar function, while obviously many will do multiple functions. So subtle changes may have multiple effects. Nevertheless, if you have a lot of these situations where there are individual mechanisms providing multiple functions, and then a single function having multiple mechanisms that provide for it, what you may find is that, in a way, anything that affects the some other subsidiary of that mechanism will have a cascading effect on the function itself. And this provides you with layers of abstraction. So in treatment, you may begin to see that you're able to change a couple of ancillary genetic factors, and then these will have a lift of a certain percentage or a drop of a certain percentage in patient outcomes. And that isn't to suggest that they're directly affecting what is the deterioration or the improvement situation, but they're having some, as I said, ancillary effect, and that this is acting in a support mechanism that's then going on to change what is actually happening on a subtle level at the area of interest where things are actually happening. And this is a great challenge in therapeutics generally, like to assess, all right, so what are we actually doing? Or even in diagnosis, like when you're looking at the genetic markers, for example, is to find out, okay, when a gene changes in this way, or multiple genes change in this way and become maladaptive or mutant genes, how much effect is each gene having in the outcome? What percentage is this gene contributing to our problem? And then again, that becomes a very difficult mechanism to assess, because we simply don't have that much information at this point, and it's ongoing work, it's ongoing research, and it's very interesting, and I'm hoping to see more information brought into the public sphere in the future. But at least from the perspective of myself, where there's a very fair criticism to say I'm not addressing things in a highly technical way, I would say that a large part of that is because highly technical information on the whole isn't available in its completion. So additionally, another criticism that could have been leveled at my presentation previously was the real lack of any follow-up. So future projections beyond just alarmist rhetoric, which isn't what I intended, but fair enough. I didn't really provide any information as to how could the way we behave reasonably change to attempt to address the situation. Well, Obviously, my advice wouldn't be, don't go out in the rain or don't visit the seaside. That isn't what I was suggesting at all. I understand that from the conversations I've had with people who have watched the video since, they have become anxious about the situation, and I do stress that these are very preliminary hypotheses from only a limited source of information, and the rates of incidence are still very, very low. While I do perceive there to be an increase, specifically in young people, and I do see that there is some evidence to suggest that there are, again, a proliferation potentially of cyanotoxins. The concentrations still aren't necessarily anything that to be overly concerned about. However, if I could elaborate on the last video, what I would say is, moving forward, probably what we will need to be doing is having more efforts in marine biology to understand exactly the different types and the incidence rates for different types of cyanobacteria, where they're occurring, how they're proliferating. Is there regional changes to how frequently we're probably going to see them? I mentioned earlier, for example, that people in sub-Saharan Africa, having been in high temperature environments for a long time, may be more resilient, either on a genetic level or an epigenetic level, to processing types of cyanotoxins. And so would it be reasonable to conclude then that either they have had presence longer with a cohabiting situation with cyanobacteria, or alternatively, maybe there's something in the environment that stifles the full accelerative blooming, the algal blooms that we may now be perceiving in different areas of the world. And if that's the case, if there is something inhibiting it in that local region, understanding that and seeing if we can reproduce that environment in other places would be very useful. For example, if there's too many local competing cyanobacteria or other bacteria, maybe making sure there's a reasonable diversity of those in every place, to ensure that there's not just one that's, the most harmful version is having a monopoly over the resources in a given area, and they're being able to bloom and cause problems. Yeah, if there is some natural ameliorant to that situation that we can investigate, absolutely, I think that's worth investigating, and that could be a potential of interest to the future. As I said, marine biologists or meteorologists looking carefully at bloom activity and reporting it in a very similar way that we report the weather today could be a staple of the future, something that could be reasonably accomplished if we are seeing certain confirmed dangerous algal blooms in places that we understand. I mean, here's one point, for example. Should surface temperature be rising, and then imagine salination had some impact on this. If the water was becoming less salinated, that would then have an impact on the size, scale, and location of algal blooms. Okay? And then you may be seeing new cases arise of neurodegenerative conditions under my hypothesis that would be appearing in places or in people that it wouldn't have before. That could be of great interest. All right. Looking on the more global meteorological scale, if there is a change in weather patterns or patterns of the paths which like the transatlantic drift or the jet stream, things like this, where there's a movement of those particles changes. Again, we may need to address it differently in the future. And in the terms of, okay, if algal blooms are happening more often, can we make predictions as to where they're happening and where they can evaporate or aerosolize in significant quantities that they become a health concern? In which case, we'd need to address very carefully the math involved in, all right, if water is evaporating here, is it very likely to fall? And if it's likely to fall in the populated area as precipitate, should the people then be informed so they can make informed choices about whether or not they want to go out in that situation, or If it's, for example, like the study was in the end of the last video, if they're able to detect it in significant quantities on the top of mountains or in mountain ranges, then at least you could advise the visiting public and the tourism board of saying that there is a potential risk in this area, given that the rainfall or the snowfall that provided the snow for this particular piste or slope or range came from a area that was evaporating at a time of an algal bloom. And, you know, global changes in sea temperature and global changes in temperature and CO2 proliferation and concentration are going to affect, or very well likely going to affect, not just algal blooms, but also how weather patterns react. So weather patterns will change. If the seas are warmer in different areas, that may cause, again, like the transatlantic drift to change position, so that maybe it'll be higher or lower, and then that will change with how the weather patterns interact with the European continent. Or, I mean, it could go the other way, for example. So if we were liable to see more storm surges, if that has a disruptive effect on algal blooms, would we therefore see less? In turn, less neurodegenerative conditions coming up in certain places. That would be an interesting dynamic we could investigate. Again, alternatively, like I was saying, if the process of the water cycle, of the water evaporation, is happening at different places due to a changing in weather patterns and a changing in air consistency and the heating of the environment, you would then need to change you need to accommodate any sort of public warning on those grounds as well. So you need to say, you know, where the water that used to drop on you as precipitate used to come from roughly this area in the North Atlantic. Now it's actually coming from here or closer to here, and these are more liable to be areas of algal bloom. So one thing maybe I didn't address in the last video as well was that, for example, you see that there appears to be, while broadly over the worldwide, you see to actually have a fairly steady state of incidence for neurodegenerative conditions. There are some anomalies within that data, some specifically in East Asia, which is very interesting. I already mentioned the difficulty of assessing the situation in sub-Saharan Africa due to a lack of studies. So it's difficult to see if there's anomalies there, and I cited already the studies involving African Americans and the apparent low incidence rates in their communities, but we do understand that in the context of other information that may be explained. But yeah, it is interesting to see that it does appear to be in East Asia specifically, like there may be some anomalous readings, or maybe not anomalous, maybe just showing a generally lower trend. In one study I found in front of me right now, it referenced Malaysian diaspora, and it spoke specifically, because Malaysia is quite an interesting mix of individuals from a number of continents. Historically, population moves as a diaspora through that area. I mean, it's been settled by multiple populations. And there was interesting finds in regards to, for example, people of South Asian origin, so the Desi diaspora there, and they did seem to present differently. They presented a little bit earlier with symptoms, and their outlooks weren't always as favourable. So that was a very interesting data point. And again, I would actually say that Malaysia is a very interesting location to look at because of its natural diversity. It does provide a much more balanced view as a study than you may find in a much more heterogeneous population. I've since had some discussions as well. Again, this is sort of acting not only as a criticism of my original video, but a bit of an addendum to it as well. And this is that we were discussing how water companies get rid of cyanobacteria and cyanotoxins in water. And it was quite interesting to find that when we analysed from a sort of existential perspective, the methodology they were using to treat the water, we did find that there were similarities to dietary habits in East Asian countries, specifically the drinking of tea. So it was postulated at the time that, this wasn't included in the video, but was a discussion afterwards, that if you were unsure of a water source, what steps could you take to hopefully clear it potentially, or reduce your potential for consuming cyanobacteria or cyanotoxins. And following the model of, as I said, water treatment, it was this notion that you would heat it first, okay? You would boil the water, obviously, and then you may introduce some sort of carbon sink into it. And it was an interesting comparison being made to the preparation of tea. The preparation of tea essentially follows the same system. It's the heating of water for a relatively short period, but nonetheless it's boiled thoroughly, and then a carbon sink is added to it in the form of dried leaves, essentially, which is it is organic matter. And could it be in a significantly absorptive state that it would be able to reduce the content of cyanotoxins in the water that you're drinking? And I think maybe that's a very interesting experiment to do, to find out whether or not it does provide that function. And is the drinking of tea in that way perhaps one behavioural mechanism that's developed mimetically to counter the effects of cyanotoxins? Anyway, I think I'll leave this video there. I think I've added a bit more. I've changed the way I've looked at it. Again, I would love to extend my appreciation for the people who make a lot of this information publicly available, so we are, as a society, allowed to meditate on this information and see if we can provide any benefit. Even if I just add additional noise to an already very difficult field, that makes sorting through useless information even more difficult. I sincerely hope that isn't what I've done, but I acknowledge that just a little bit of self-awareness on my part of being perhaps naively enthusiastic will be disarming to some people and give me their forgiveness for any mistake I may make. Nonetheless, thank you very much for listening. I hope you found it informative, and if you have any further questions or queries, I'd love to hear from similar-minded people or anyone with any experience in the field who can advise me further on these investigations. Thank you very much. Have a nice day.